Hi, thanks for joining me. It's been a while since I last uploaded. Apologies for that. However, I'm keen to make some more maths videos. Let's get going with this one. We have three endpoints on the plane such that no three are collinear. We want to prove that we can always construct n disjoint triangles using these points as vertices. So we have 3n, so if n was 10, we'd have 30 points scattered across the plane such that no three lie on the same straight line. And we want to prove that from these 30 points, we can then go ahead and construct 10 disjoint triangles using those points as vertices. And by disjoint, no two triangles are allowed to share edges or intersect or even share vertices. So we have to use all 3n of the vertices. Anyway, if you want to have a go at this problem, pause the video now and give it a go for yourself. And I'm going to jump straight into a solution. Okay, so the way we're going to solve this problem is perhaps the most intuitive way to solve this problem, and that's by induction on n. So the base case is pretty straightforward. When n equals 1, we just have 3 points on the plane, and they're not all on the same line, so kind of by definition, we can construct a triangle out of them. So we've got, say, this point, and this point, I don't know, and of course you just construct a triangle, and it's important that they're not all on the same line, because if they were all on the same line, obviously you can't construct a triangle. It's an if and only if relationship. Anyway, the base case is done. Now let's assume it holds true for n equals k, i.e. if you give me any collection of 3k points on the plane, such that no three of them lie on the same straight line, then I can construct k triangles from it, k disjoint triangles. Now what we want to do is look at n equals k plus 1 and see if we can use the n equals k case, which we're assuming is true, to help us prove the n equals k plus 1 case. So let's suppose we have 3k plus 3 points on the plane. So we've got 1, and yeah, we're going to just assume my drawing makes it so that then no 3 lie on the same straight line. So we've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, let's give it a dot there. Cool. So we've got, this is the case n equals k plus 1, so we have 3k plus 3 dots or points on the plane, such that no 3 lie on the same straight line. What we want to do is consider the convex hull of these points. So the convex hull is simply the smallest shape we can fit on the plane, which is convex and contains all these points. So the convex hull will probably look something like this. So I'll use dashed lines to draw it. Something like that. So it's a convex shape, it's as small as possible, which includes all the points, or kind of, boundaries, or provides a boundary for all the points to lie in or on. So we have this convex body here, and now what we're going to do is just choose one of the points on the boundary, let's say this one, and we're just going to draw a straight line through that point, which doesn't kind of enter into or touch the convex body at any other point but this point here. So say this straight line here will do. And now I'm just going to put an arrow on this straight line here, just so it's we have a kind of sense of orientation. Now, one thing we notice is to the right, so in the direction of the arrow, at the moment, we have all the points that we're considering, apart from perhaps this one, which is on the line, but every other point that we're considering is to the right of this arrow. But if I were to rotate this line 180 degrees, so come across like this, and bring up here, so the arrow is now up here, well, now I have 0 dots kind of facing the direction of, the arrow. So I've gone from having all the dots to now having 0 of the dots in this rotation process. So also, because no 3 dots lie on the same straight line, going from this point here where we have all the dots, so it's 3k plus 2 dots, to now having 0, in this process of rotating this line, we're kind of knocking off a dot one by one. And it's important that it's one by one, and that's because no 3 points lie on the same straight line, because if they did, then it could be that we knocked off 2 in the same kind of go. But because we're knocking them off one by one, we've gone from 3k plus 2 down to 0. There must be a point at which this kind of rotation will mean there's just 2 dots left in the direction of the arrow. So that's probably going to be somewhere about here. So once I've rotated the line, so it's about here, so I just have these guys here, 2 dots left in the direction of the arrow. Now, if I get rid of this original line, what do we have? Well, beneath this line, we have 3k plus 3 minus 1, 2, 3. So we have 3k dots here. And remember, there's still, still has the property that no 3 points are collinear, etc. And that's because originally there were no 3 points that were collinear, so we've only gone and taken some points away. So certainly these guys here have this collinear property. And now we have 3 points here, and kind of by construction, they're not going to be on the same straight line. So we can draw a triangle here. That's going to give us one triangle. And then to get the other k triangles, well, we can just use our assumption. We've got 3k points here, no 3 of which lie on the same straight line. Hence, we can construct k triangles. And quite clearly, because these guys are disjoint from one another, and they're all very clearly going to be disjoint from this guy here because of this line here, clearly separating them. We've now done the inductive step, and we've constructed k plus 1 triangles from 3k plus 3 points on the plane. Anyway, that concludes the proof, and I hope that has all made sense. Thank you for watching. Next week, I should be making some videos for the invariant summer puzzle competition. So if you don't know what that is, I'll leave a link for that in the description below. It's videos I've made in the past before, but the Maths Society at Oxford are running a competition over summer where each week they're going to release 3 problems, and I'm going to be making the solution videos for those problems at the end of each week. Anyway, that's all for today. Thank you for watching. Have a great day.